All right, this is a continuation of our work on series. If you look at number 89, right down there, if we have 1 minus x plus x squared over 2 factorial minus x to the third over 3 factorial. That reminds me a lot of e to the x, which is 1 plus x squared over 2 factorial plus x to the third over 3 factorial. So this one right here must be e to the negative x, because somebody's taken an e to the x and all of the odds have a negative x in them, so they put in e to the negative x became minus. This one stayed positive, this one turned negative. So I recognized this, and you needed to recognize this as e to the x. This is a calculator active problem, so I can tell by the number and the decimals. Of course, you wouldn't have multiple choice this year anyway, you'll be using your calculator. But you might have to do this so for your response. So I would say I know that this equals e to the x. I might even take a minute to form this. And then I want to know where it intersects x cubed. And so I'm going to go to my calculator. I'm going to write on my page. I want to see where e to the negative x equals x to the third. And so I'm going to go to my calculator, and I'm going to have e to the negative x, and I'm going to see where it intersects x to the third. And I'll just look at it on the standard viewing window first and do calc intersect. But you want to establish, you want to establish this first. So that's e to the negative x, and I should be getting x cubed, and then second calc 5, and there's only 2 graphs here, so I can kind of quickly go enter, and so you get 0.773, so that one would be A. And so you would say add x equals 0.773, and this would be enough to say on that. Okay, so now I'm going to look at another sheet. Let's see. I don't remember which ones I want. Let me look. Okay, this one I think. This was 2003. So let me move this over so we can see the slides. And I'll be giving you some of these to work for homework, and maybe explain to the class. All right, so I gotta move this back out again. Okay. All right, so for what values does this converge? Now, if the integral converges, and this is, I guess, technically the integral test, but I want to go over this anyway. If the integral converges, then also the series would converge. So I'm really looking at this series, x to the 2p, as n goes from 1 to infinity, or p goes from 1 to infinity. I guess they would call this x to the 2n, as n goes from 1 to infinity. Anyway, by the p-series test, this only converges. This is the one where you want it to be big on the bottom to get smaller. So this would have to be greater than 1. And so it would happen when n or p is greater than 1/2. So it'd be answer choice C. All right, number 10. Notice on 10 they say, what is the value? When they say, what is the value, that implies that it's geometric. Like, they don't want to just know if it converges, they want to know what it converges to. And that's when you would, if they say, what is the value, be on the lookout for geometric. As I've said so many times, always write out a few terms so that you see what's going on. If you fill in 1, you get 2 squared over 3 to the first. If you put in 2, you get 2 to the third over 3 to the second. If you put in 3, you get 2 to the fourth over 3 to the third. Well, I can see on the top I'm multiplying by 2, and on the bottom I'm multiplying by 3, and it's remaining all positive, so I don't need a negative ratio, but that could also work. Since this is less than 1, That means this is geometric and it does converge. So that's why I encourage you to write out a few terms so you see something happen. And so I'm going to say a sub 1, which is another reason you want to write out. You want to know your first term in that series, 4/3. No matter what this starts with, if that started with 8, you'd fill that in and find out what your first term is in that sequence. A sub 1 over 1 minus r gives me 4/3 over 1/3. Multiply by the reciprocal and you get 4. And so the answer to that one is C. All right, the next one, 11. All right, this is a Maclaurin series, which means it's a Taylor series centered at 1. And I'm trying to get the whole question in here. Okay, so the Maclaurin series for 1 over 1 minus x. So somebody took this function and wrote a polynomial for it, and they tell me just straight out that it is built by this. So remember, to build this Maclaurin or Taylor polynomial, somebody would have had to find f of 0, then f prime of 0, then f double prime of 0, and f triple prime of 0. And if we did all of that, they'd just gone in and told us it would give us x to the 0, x to the first, x to the second, x to the third, and so on. So what that means is the more I write of this, it actually to settle on that rational function. All right, so it says now, all right, so establish this is equal to this by writing out a few of the terms. And now they ask me what x squared over 1 minus x squared would be if I know 1 minus 1 over x. All right, so here, let's see what we can do with this as far as this is concerned. If this is f of x, well, first of all, let's look and see what we have that's the same, because I want to fill it into some sort of power series. Like on the top, I notice instead of a 1, I have an x squared. And on the bottom, I have 1 minus x squared and just not just 1 minus x. And so I'm trying to draw into this polynomial, some other polynomial situation. So one thing I think of is x squared times 1 over 1 minus x squared. Oh, okay, well that gets it, because this is a polynomial x squared, and this is 1 over 1 minus u, like whatever is x in here can be substituted in here. So I have x squared times 1 over 1 minus x squared, and I'm following this pattern, and everywhere there's an x, I can put in an x squared instead. This x to the 0 is just 1, plus x, but everywhere there's an x, I'm putting x squared. And this is x squared squared, so that's going to be x to the 4th. This is x squared cubed, so it's going to be x to the 6th. And so that gives me x squared plus x to the 4th plus x to the 6th, sorry, couldn't read my writing, plus x to the 8th, and so on. And so now, does it match any of those on 11? Let's see, it should be D. I don't think it's really 11. Is this 11? Yeah, on 11. And so I got D. So the key is to notice they establish a polynomial and then they ask you a similar polynomial expression. Okay, so now let's go to 20. It's sort of similar. All right, so number 20. All right, so you have this function given by the Maclaurin series, which is x squared over 2 factorial, x to the 4th, which you can barely see there, but you can see it on this other screen, x to the 5th over 3 factorial. They already wrote some of it out for us. And they tell you that it's got this general term, x to the n plus 3 over n plus 1 factorial. And so it says, which of the following is an expression for f of x? So I'm having to like pull this apart to figure out what f of x is. And so it says this is our function f for a Maclaurin series. A function f has a Maclaurin series given by this. And this is its pattern in general terms. And let me see if there's anything else I'm missing over here before I go on. Let's see if I can pull that. Okay, yeah, so that's all we had. All right, so it says, which of the following is an expression for f of x? So I'm thinking to myself, how would I get this? Like, that looks kind of familiar. Like, for instance, I'm thinking e to the, well, it's not alternating. So since it's not going plus, minus, as of right now, I might rule out A and C. Because on A and C, of sign, I would expect to alternate back and forth, back and forth, back and forth. I don't much think it's going to be B, because another reason is I notice the powers are just going by 1. So I'm sort of thinking of an e to the x. And e to the x, you know, is 1 plus x squared over 2 factorial plus x to the third over 3 factorial. And I compare it with what I have here. And so now I'm thinking, maybe let's try D. X squared e to the x minus x cubed minus x squared. So let's literally try this polynomial. Because I didn't think it was one of the trig functions since it wasn't alternating. I thought it would be this something with e to the x in it. It's just my first try. All right, so I have x squared. E to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and on and on and on. So I'm about to erase this so I can write, and I substituted that in there. So let me get rid of this so I can write underneath it. And distribute this polynomial and see if it's right. Again, you would probably be asked like this on this year's AP exam to write this out. So you would go x squared times, you would know e to the x is on your study guide, and now you have the rest of the polynomials minus x cubed minus x squared. Now I'm going to distribute this and get x squared plus x cubed plus x to the fourth over 2 factorial plus x to the fifth over 3 factorial, actually in this parentheses, and then after you finish all of that you'll have minus x cubed minus x squared. So this cancels and this cancels, and I have x to the fourth over 5 factorial, x to the fifth over 3 factorial, still growing from this multiplication. And so I tried D first just because it felt right to me, and so 20 is D. All right, now let's go to 22. This one you probably wouldn't have, so I'm going to move on. I think that's something called a direct comparison test, which they didn't make us learn. All right, let's go to 24, which just means it was number 24 on an AP exam at some point. I think they even tell us the year on the worksheet. But anyway, on 24, which ones diverge? Notice the word diverge. So make sure you're looking at the words, underline them when you're doing your free response this year. Always look and see where this starts. And this is sine of 2 over pi to the n power. That's really weird. If I put in 0, I get sine of 2 over pi to the 0, which is 1. Then I get sine of 2 over pi to the first, sine of 2 over pi to the second. I'll get sine of 2 over pi, pi. I was thinking ahead of what I was going to say, pi to the third, and so on. This is to the third. Okay, now what I notice here is that this is actually a number. Sine of 2, I don't know how big it is, but at the most, it could be 1, and pi's around 3, and so I'm actually multiplying by something that is a ratio less than 1. I don't know how big sine of 2 is, but I know it can't be more than 1, and the bottom is a constant, so these are constants. It's just I might as well be sort of multiplying by that. And so this one is actually going to converge because the absolute value of my ratio is less than 1, because I'm multiplying by sine of 2 over pi. These are all just numbers. All right, so it's not 1 because it asked me which ones diverge, and that one converges. All right, number 2 diverges by the p-series test because you have 1 over n to the 1/3 behind the sigma, and p is less than 1, that means it diverges by the p-series test. And on 3, let's see, I have e to the n over e to the n plus 1, and I have the sum as n goes from 1 to infinity. If you take the limit of this as n approaches infinity for the nth term test, the nth term would go to this, which is a 1-to-1 ratio, not 0. Your nth term equals 0. If you wanted to like write it out better than I'm writing in this corner, your nth term does not equal 0. And so this one would also be divergent. And so it's D. It would be 2 and 3. All right, let's go to number 28. This is a Taylor series about x equals 0. All right, I think I'm out of cute slides, so I'll just go to a not cute slide. Okay, so on 28, which is a coefficient of x squared in the Taylor polynomial, sorry, I'll write it where you can see it, coefficient of x squared in the Taylor polynomial of 1 over 1 plus x squared about x equals 0. All right, now this one is not one that you've memorized, and so we're actually going to have to write this one a bit. This is y. In other words, I have f of x is equal to 1 plus x to the negative 2. F prime of x is negative 2 times 1 plus x to the negative 3 times the derivative of the inside, which is 1. F double prime of x is going to be 6 times 1 plus x to the negative 4 times the derivative of the inside, which is just 1. All right, so this second derivative is 6 over 1 plus x to the 4th. And by the time I get to my second derivative, so this is how you would build it. You would say f of 0, which if you put in 0 right here, you would get 1. Then you would say plus f prime of 0, which is going to be negative 2 after you put 0 in here, and you'll have 1 to the negative 3. Negative 2, so f prime of 0 times x to the first over 1 factorial. And then the next one you're going to have plus f double prime of 0, which is going to be 6 after you put in 0. And so you get just 6 x squared over 2 factorial. And I feel like I've done something wrong here because I already know the answer is D. Oh, this is going to be right, sorry. So this is my coefficient of the x squared term. My coefficient of the x squared term is created by f double prime of 0, in this case because it's centered at 0, times x minus 0 squared over 2 factorial. So I needed f double prime of 0, which is 6, x squared over 2 factorial. So you have 6 over 2 times 1, which gives you 3. So the answer choice is D. All right, then I think one more. All right, so on 77, you have a polynomial that's written, a Taylor polynomial. There's 3x squared minus 5x cubed plus 7x to the 4th plus 3x to the 5th is a 5th degree Taylor polynomial. It's about x equals 0. And what is the value of, it looks like f triple prime of 0. Okay, so f triple prime of 0 I would think would come from this x to the 3rd term, because by a Taylor polynomial you would have f triple prime of 0 times x minus 0 to the 3rd over 3 factorial. Don't forget the entire coefficient is being built right here. Okay, so by the very fact that I have negative 5 as my coefficient, I know that f double prime, triple prime of 0 over 3 factorial, there's a factorial in there, has got to all transcend or figure out to be a negative 5, because that's my coefficient of x cubed. So don't forget x cubed's coefficient is created by triple prime of c times x minus c to the third, in this case 0, over 3 factorial. And that all must have worked out to be negative 5. So f triple prime of 0 is negative 5 times 3 factorial, which is 3 times 2 times 1, which is 6. So I get negative 30, and so it's answer choice A. All right, now you're going to be doing some for homework, and I'm not giving you the answers to it, but you could look up the answers to it. Let me find it for you, and I'll pull it up because I'm sorry it's kind of fuzzy, but I really liked where I got the questions from. So let's see, what did I call it? Series. Oh, I don't see it in my list. It's not coming up. Let me go in my Word docs. And it might be right behind it. Nope, that's not it either. So let me look at recents. Okay, maybe this is it. Oh, this is it. Okay, so the questions might look a little fuzzy to you. Well, I don't know. Let's see, Grand X. So I have to give myself access to look at it. Sorry, I've got a lot of stuff open. It's really slow. Okay, so I'm sorry. It looks kind of fuzzy, so it's not your eyes. It's just that I really liked the place that I got it from, and I didn't want to hunt for them actually at this time of night on all the other places where these are being drawn from. And so haven't given you the interest to them. You might find them or just feel really comfortable about it, but you should be able to do all of these based on what I've just told you. Like here, e to the 3x, you want the coefficient of the x cubed term. And so you should work these. I believe there's 12 problems, and again, I apologize for the fuzziness. Also to your last 2 free response problems, and print out your study guide so that you're ready for the practice test on Thursday.